Hi friends, Assalamu alaikum. Welcome to Inside Winner. A winner is a dreamer who never gives up. Our channel gives you powerful mental tools to master tough subjects. If you are watching the channel first time, please subscribe the channel and click the bell button so that you will get notification of new videos.
Repeated multiple choice questions. Question number 1. The horizontal distance is measured in undulated areas by option A, chain, option B, subtence bar, option C, both of the above, option D, sextant. So we can check the options. Chain. The most accurate and common method is used for measuring distance is chaining. And the instrument used for chaining is chain. We know that the chains are also two types, metric chain and British chain. The British chain is again divided as Grunder's chain, revenue chain and engineer's chain. Chain is composed of pieces of galvanized mild steel wire 4 mm in diameter called links. The adjacent links are connected by using 3 circular or oval rings. The length of one link is the distance between the centers of the two consecutive middle rings. The first and last links contains a brass and the bolt used for connecting the brass handle and the link is known as eye bolt. Also, the joint is known as swivel joint. The metric chains are made in length of 20 and 30 meters. Here, a 20 meter chain contains 100 links. The length of a link is 20 centimeter. At every 1 meter provided with a brass ring. At 5 meter provided a single-headed tally mark. At 10 meter provided a double-headed tally mark. A chain accompanying with 10 number of arrows. The permissible error in 20 metric chain is plus or minus 5 mm and the permissible error in 30 meter metric chain is plus or minus 8 mm. When we consider the British chain, the first one is Grunder's chain. Grunder's chain is having 66 feet length and the number of links is 100. It means that length of one link is 166 feet. It is very convenient for measuring distances in miles and furlong and measuring land when unit of area is in acre. And revenue chain is having 33 feet length. Number of links is 16. And revenue chain is suitable for cadastral survey. And the third one is engineer's chain. Engineer's chain is having 100 feet length and the number of links is 100. Length of one link is 1 feet. These are all about chain. Now, the next option is subtence bar. It is a horizontal bar used in the subtence system of surveying by tacheometry. It is held at a distant point and its distance is calculated from its non-length and the angle that it subtends at the observer's eye. It is a bar made up of a fixed length with targets at the ends and with a spirit level at the center for leveling the bar on its stand or tripod. This instrument is used to measure length based on trigonometric methods or simply put based on the properties of a triangle. And its mode of use is an angle measuring device such as a Theodolite is set up on one end of the line of inrush and the bar at the other end. The Theodolite is then used to measure the angle between the two targets mounted on the bar. And the mode of calculation. Here the angle measured and the length of the bar are then used to calculate the distance between the bar and the angle measuring instrument based on trigonometric properties of triangle. That is knowing one length and one inverted angle of a triangle. Now fourth option, sextant. What is sextant? Sextant is angle measuring device. And a sextant is a doubly refractive navigation instrument that measures the angular distance between two visible objects. The primary use of a sextant is to measure the angle between an astronomical object and the horizon for the purposes of celestial navigation. A sextant is an instrument used for measuring the angle between two visible objects. Both horizontal and vertical angles can be measured using a sextant. It contains two mirrors which are arranged in such a way that the observer can sight both the objects at the same time. So, the answer is option B, subtence bar. The horizontal distance is measured in undulated areas by subtence bar. We cannot use chain for measuring distances in undulated areas. We will not get the actual measurements. So, subtence bar is the answer. Now, let us move to second question. The zero is fixed below the north and in option A, prismatic combust. Option B, surveyor's combust. Option C, Ferguson's combust. And option D, all of the above. Answer is Option B, in survey's compass. Let's check the options.
In prismatic compass, needle doesn't act as index. Graduated ring attached to the needle here, and graduations are in whole circle bearing. But in survey's compass, needle acts as index, graduated ring attached to box, and graduations are in quadrantal bearing. Graduating indicates same angles with north and south. Survey's compass, tripod is mandatory.
First of all, what is combust surveying? Combust surveying is the branch of surveying in which the position of an object is located using angular measurements determined by a compass and linear measurements using a chain or tape. Where we can use this combust survey? If the surveying area is large, chain surveying is not adopted for surveying, rather combust surveying is employed. If the plot for surveying has numerous obstacles and undulations which prevent chaining, combust surveying is used. If there is a time limit for surveying, combust surveying is usually adopted. And combust surveying is not used in places which contain iron core, power lines, etc., which usually attracts magnets due to their natural properties and electromagnetic properties respectively. Combust surveying is done by using traversing. A traverse is formed by connecting the points in the plot by means of a series of straight lines. Now, what is a prismatic compass? Prismatic compass is a portable magnetic compass which can be either used as a hand instrument or can be fitted on a tripod. It contains a prism which is used for accurate measurements of readings. The greatest advantage of this compass is both sighting and reading can be done simultaneously without changing the position. Major parts of a prismatic compass are magnetic needle, graduated ring, adjustable mirror, sliding arrangement for mirror, object vane, eye vane, metal box, glass cover, hose hair, etc. And adjustment of a prismatic compass is of two types. One temporary adjustment and the other is permanent adjustment. This temporary adjustment includes centering, leveling and focusing the prism. And here centering is the process of fixing the compass exactly over the station. And centering is usually done by adjusting the tripod legs. Also a plumb bob is used to judge the accurate centering of instruments over the station. And leveling, the instrument has to be leveled if it is used as in hand or mounted over a tripod. If it is used in hand, the graduated disc should swing freely and appears to be completely level in reference to the top edge of the case. If the tripod is used, they usually have a ball and socket arrangement for leveling purpose. Prism can be slid up or down for focusing to make the readings clear and readable. And the permanent adjustment of a prismatic compass is same as that of surveyor's compass. Now let's check what is surveyor's compass. Surveyor's compass consists of a circular brass box containing a magnetic needle which swings freely over a brass circle which is divided into 360 degrees. The horizontal angle is measured using a pair of sights located on north-south axis of the compass. They are usually mounted over a tripod and leveled using a ball and socket mechanism. Surveyor's compass also have two types of adjustments, permanent and temporary adjustments. Temporary adjustments are same as described in prismatic compass, but the permanent adjustments are done only in the circumstances where the internal parts of the prism is disturbed or damaged. There are adjustment in levels, adjustment in pivot point, adjustment in side vanes, and adjustment of needle.
In surveyor's compass, the zero is fixed below the north end and south end. So our answer is option B, surveyor's compass.
Now let's move on to third question. 1 hectare area is equal to option A 100 meter square, option B 1000 meter square, option C 100,000 meter square, and option D 10,000 meter square. And the answer is option D 10,000 meter square. 1 hectare area is 10,000 meter square. Now let's move to the fourth question. The agonic lines are those isogonic lines which have option A 0 declination, Option B, negative declination. Option C, positive declination. And option D, all of the above. Now let's check the options. And the answer is zero declination. The agonic lines are those isogonic lines which have zero declination. What is an isogonic line? Isogonic lines are lines on the Earth's surface along which the declination has the same constant value, and the lines along which the declination is zero are called agonic lines. Okay. Now let's move to the next question. Setting out a simple curve by two theodolite method does not require option A, angular measurements, option B, linear measurements, option C, both angular and linear measurements, option D, none of the above. In two theodolite method, curves are staked out by angular measurements only. The underlying principle of this method is that the deflection angle between a tangent at any point on a circle and a chord is equal to the angle is the chord substance in the alternate segment. So our option is option B, linear measurements. Setting out a simple curve by two theodolite method does not require linear measurement. It only requires angular measurements. So option B is the answer. Now let us move into the next question. The number of horizontal cross wires in a stadia diaphragm is option A 1, option B 2, option C 3, option D 4, and option C 3 is the answer. You know that there are 3 cross wires in a stadia diaphragm. Third question. Bowditch's rule is applied to option A, an open traverse for graphical adjustment, option B, a closed traverse for adjustment of closing error, option C, determine the effect of local attraction, option D, none of the above. Now, where we can use Bowditch's rule? Actually, Bowditch's rule is used when the angular and linear measurements are equally important. And the equation for Bowditch's rule, correction to latitude or departure of any side is equal to total error in latitude or departure all into length of that side divided by perimeter of traverse. Bowditch's rule is applied for balancing the traverse when the angular and linear measurements are equally important, and it is also known as combust rule, and it is used when angles and distances are measured with the same relative accuracy. And we know that Bowditch's rule is applied to a closed traverse for adjustment of closing error. So our answer is option B, a closed traverse for adjust of closing error. Bowditch's rule is applied to a closed traverse for adjust of closing error. Question number 8. The type of surveying which requires least office work is option A, tacheometry, option B, trigonometrical leveling, option C, plane table surveying, and option D, theodolite surveying. The answer is option C, plane table surveying. Plane table surveying requires least office work because all the distances are found from the field itself. So it is the very simplest method and which requires least office work. Now let us check each options. First one, tacheometry. Tacheometry is a branch of angular surveying in which the horizontal and vertical distances are obtained by instrumental observations. Thus, chaining is entirely eliminated in tacheometry. This method is most rapid but less accurate. The accuracy of tacheometry is less than that of chaining. And the primary object of tacheometry is the preparation of contour map or plan. The instruments used in tacheometry are a tacheometer and a leveling of stadia rod. Now, tacheometric methods. The different tacheometric methods are stadia method and tangential method. There are 2 types of stadia method, fixed hair method and movable hair method. Fixed hair method is the most commonly used method in tacheometry. In this method, the stadia hair interval is fixed and the staff intercept is taken. The required horizontal and vertical distances are computed from the staff intercept. In case of inclined sides, the staff may be held vertically or normal to the line of sight. We have the formula D is equal to Ks plus C, where K is the multiplying constant and C is the additive constant. Actually, movable hair method is rarely used. In this method, the stadia wires can be moved by means of a micrometer screws. The staff is provided with 2 targets fixed at a known distance apart, usually 3 meters. The variable stadia interval is measured. The required distance may be computed from this value. Tangential method is used when the telescope of the instrument is not equipped with a stadia diaphragm. In this method, a staff is fitted with two targets at a fixed distance apart. Usually 3 meters is held at the station. Vertical angles to the two vanes are observed with a theodolite. And calculation of distance in stadia method is used by the equation horizontal distance d is equal to ks plus c, where k is equal to f by I and c is equal to f plus d, where s is the staff intercept, f by I is called the multiplying constant of k and its value is 100, f plus d is called additive constant. Analytic lens is provided to eliminate the additive constant, and analytic lens is a convex lens. Now let's move to trigonometrical leveling. Trigonometric leveling is the branch of survey in which we find out the vertical distance between 2 points by taking the vertical angular observations and the non-distances. The non-distances are either assumed to be horizontal or the geodetic lengths at the mean sea level. The distances are measured directly or they are computed as in the geodetic survey. The trigonometric leveling can be done in two ways. First one, observations taken for the height and distances, and second one, geodetic observations. In the first way, we can measure the horizontal distance between the given points if it is accessible. We take the observation of the vertical angles and then compute the distances using them. If the distances are large enough, then we have to provide the correction for the curvature and refraction, and that we provide to the linearly to the distances that we have computed. In the second way, that is geodetic observations, the distances between the 2 points are geodetic distances and the principles of the plane surveying are not applicable here. The corrections for the curvature and refractions are applied directly to the angles. Now we can move to the third option, plane table survey. Plane tabling is a graphical method of surveying in which the field work and plotting are done simultaneously. It is most suitable for filling the details in a plot. It is used for small scale mapping in which great accuracy in detail is not required. The plane table consists of a drawing board mounted on a tripod and a straight edge called an alidade. The drawing board is made up of well seasoned wood such as a pine or teak and varies in size from 40 cm by 30 cm to 70 cm by 60 cm or 50 cm to 60 cm square. The alidade consists of a metal or brass or gunmetal or boxwood straight edge about 50 cm long. The beveled edge of the alidade is called the fiducial edge, and there are two types of alidade, plain alidade and telescopic alidade. The accessories of plane table are a trough combust, a plumbing fork or U-frame with a plumb bob for centering the table, and a waterproof cover to protect the sheet from rain. The operation of keeping the table at each of the successive stations parallel to the position which it occupied at the first station is known as orientation. The orientation is required only when the instrument has to be set up at more than one station. There are two methods of orienting the table. First one, orientation by the magnetic needle, and second one, orientation by back sighting. Orientation by magnetic needle is most accurate method. And now about the methods of plane tabling. The first one is radiation method. This method is suitable for the survey of small areas which can be commanded from a single station. And here the first in radiation method, the first one is intersection method. In this method, the point is fixed on plan by the intersection of the rays drawn from the two instrument stations. The line joining these stations is called the baseline. And second one, traversing. This method is similar to that of combust or transit traversing. Third one, resection. Resection method is used for establishing the instrument stations only. The characteristic feature of resection is that the point plotted on plan is the station occupied by the plane table. The other cases of resections are the 2-point problem and 3-point problem. 2-point problem consists in locating the position on the plan of the station occupied by the plane table by means of observations two well-defined points which are visible from the instrument station and whose positions have been already plotted on the plan. 3-point problem consists in locating on the plan the position of the instrument station on the ground by means of observation to three well-defined points whose positions have been already plotted on plan. Now, the last one is Theodolite survey. Theodolite is the most accurate instrument used for measurement of horizontal and vertical angles. It can be used for various other purposes such as laying of horizontal angles, locating points on a line, prolonging survey lines, establishing grades, determining differences in elevation, etc. The diameter of a graduated circle on the lower plate determines the sizes of the theodolite. Size of theodolite varies from 8 cm to 25 cm. 8 cm to 12 cm instruments are used for general survey and engineering work, while 14 cm to 25 cm instruments are used for triangulation work. Theodolites are primarily classified as transit and non-transit theodolite. If the telescope of a theodolite can be revolved through a complete revolution about its horizontal axis in the vertical plane, it is called transit theodolite. If the telescope of a theodolite cannot be revolved through a complete revolution about its horizontal axis in the vertical plane, it is called a non-transit theodolite. Now let us check the parts of a transit theodolite. First one, leveling head. It consists of two parallel plates kept at a fixed distance apart by foot screws. The upper parallel plate is called tribrac and lower parallel plate is called trivet. The trivet plate has a central hook through which a plumb bob may be suspended. In the modern instruments, the shifting head is provided to center the instrument quickly and accurately. And second one, the two spindles. There are two spindles or axle, one inside the other. The outer axis is hollow and its interior is ground conical to fit the central vertical axis called the inner axis, which is a solid and conical. The two axes should be coaxial. And third one, the lower circular plate. The lower plate is also called a scale plate, is attached with the outer axis. Its beveled edge is graduated from 0 degree to 360 degree in a clockwise direction. The lower plate is provided with a clamp and tangent or slow motion screw. Then the upper plate. The upper plate is attached to the inner axis. It is also called vernier plate. A clamp and tangent screw are provided for the purpose of accurately fixing the vernier plate to the scale plate. The upper plate carries two verniers with magnifiers placed 180 degree apart. Now let's study about the technical terms in theodolite survey. First one, transiting. Transiting is the process of turning the telescope about its horizontal axis through 180 degree in a vertical plane, thus bringing it upside down and make it point exactly in the opposite direction. It is also known as plunging or reversing. Second one, swinging the telescope. Swinging means turning the telescope in a horizontal plane about horizontal axis. Then centering, it means setting the theodolite exactly over the station mark. It is done by using a plumb bob. Then face left. If the vertical circle of the instrument is on the left of the observer while taking a reading, the position is called face left. Then face right. If the vertical circle of the instrument is on the right of the observer while taking a reading, the position is called face right. And then the most important one, line of collimation. Line of collimation is the imaginary line joining the intersection of the crosshairs of the diaphragm to the optical center of the object glass and its continuation. Then axis of the telescope. It is also a repeated question in all the PSC exams. Axis of the telescope is the line joining the optical center of the object glass to the center of the eyepiece. And what is vertical axis? The vertical axis is the axis about which the telescope can be rotated in a horizontal plane. What is the horizontal axis? Horizontal axis is also known as Trunnion axis or Travers axis. It is the axis about which the telescope can be rotated in a vertical plane. So the fundamental lines of a transit theodolite are the vertical axis, the axis of plate levels, the horizontal axis, the bubble line of altitude level,
and the line of collimation. Now the adjustment of theodolite. Two types of adjustment are the temporary adjustment and permanent adjustment. The temporary adjustments are made at each setup of instrument before starting taking observations with the instrument. There are three temporary adjustments of a theodolite. First one centering, and second one leveling, and third one elimination of parallax. Centering means bringing the vertical axis of the theodolite immediately over a station mark. And leveling, the theodolite is accurately leveled with the reference to the plate levels by means of foot screws to make the vertical axis truly vertical. For great accuracy, the instrument should be leveled with reference to the altitude level. Third one, elimination of parallax. Parallax is the apparent movement of image with respect to the crosshair. Parallax can be eliminated by focusing the eyepiece and focusing the object glass. Now, the permanent adjustment of a theodolite. Permanent adjustments are made to establish the fixed relationship between the fundamental lines of the instrument. And the conditions of permanent adjustment are: the axis of the altitude level must be parallel to the line of collimation. The axis of the plate levels must be perpendicular to the vertical axis. The line of collimation must be at right angles to the horizontal axis. The horizontal axis must be perpendicular to the vertical axis. If the transit has a fixed vertical vernier, the vertical circle vernier must reach 0 when the telescope level is centered. And the uses of theodolite are: it is used to measure horizontal angle by repetition, it is used to measure horizontal angle by reiteration method, to measure the direct angle, to measure deflection angles, to measure a magnetic bearing of a line, to measure vertical angle. Now let us move to the next question. Sensitiveness of a level tube is designated by: option A, radius of level tube; option B, length of level tube; option C, length of bubble of level tube; option D, none of the above. And we know that the sensitiveness of level tube is designated by radius of level tube. Option A is the answer. The sensitivity of a level tube is its capability of exhibiting small deviations of the tube from the horizontal. This quality depends mainly upon the radius of curvature of the level tube, which may vary from 10 to 300 meters. The larger the radius, the greater the sensitiveness. Sensitiveness is also increased by increasing the length of bubble and by decrease of viscosity and surface tension of the liquid in the level tube. Sensitiveness is sometimes designated in terms of the radius of curvature of the level tube, but the better way is to state the angle through which the axis must be tilted to cause the bubble to travel through one division of the scale. Now, let us move into the 10th question. In a simple curve, external distance is the distance between: option A, vertex and middle point of the curve; option B, vertex and center of the curve; option C, vertex and point of the curve; option D, point of curve and point of tangents. So the answer is: in a simple curve, external distance is the distance between the vertex and middle point of the curve. Option A is the answer. And external distance is also called as apex distance, and it is the distance from the point of intersection to the apex of the curve. And apex distance is equal to r into sec theta by 2 minus 1. That is r of sec theta by 2 minus 1. R means radius. Relating to simple circular curve, the frequently asked questions are about tangent length. What is the tangent length of a simple curve, circular curve? The tangent length is r tan theta by 2. Tangent length. Length of long chord is 2r sin theta by 2. And how can we find mid-ordinate? Mid-ordinate is equal to r into 1 minus cos theta by 2. Now let's move to the next question. Reciprocal leveling elimination. A, collimation error. Option B, collimation curvature and refraction error. Option C, curvature and refraction error. Option D, collimation and curvature error fully and refraction error partly. And the answer is option D, collimation and curvature error fully and refraction error partly. Now let's check what is reciprocal leveling. Where we can use the reciprocal leveling. Reciprocal leveling is used when there is an obstruction like point between two stations. Reciprocal leveling is the method of leveling in which the difference in elevation between two points is accurately determined by
two sets of observations when it is not possible to set up the level midway between the 2 points. Now let's move into the next question. Question number 12. An invert is taken when point is option A, having high elevation, option B, above the line of sight, option C, below the line of sight, option D, below ground level. And the answer is option B, above the line of sight. An invert is taken when the point is above the line of sight. Now 13th question. A passometer, option A, indicates the velocity of a surveyor, option B, rate of movement, option C, length of a line, and option D, number of paces covered. And we know that a passometer gives the number of paces covered. A passometer is a pocket instrument which counts the number of paces taken by a person carrying it. It automatically records the number of paces. Its mechanism is being operated by the motion of our body. Now the next question. If the surveyor gives the signal with both the hand above head and then brings them down, the indication is option A, correct, option B, fix the road, option C, pick the road, option D, move backwards. And the answer is option A, correct. If the surveyor gives the signal with both the hand above head, then it brings them down, the indication that it's okay, it's correct. Now the last question. The analytic lens is of the type of option A, convex lens, option B, plano convex lens, option C, concave lens, option D, concave convex lens. Analytic lens is a special convex lens fitted in between the object glass and eyepiece at a fixed distance from the object glass inside the telescope of a tacheometer. The function of the analytic lens is to reduce the stadia constant to 0. Thus, when tacheometer is fitted with analytic lens, the distance measured between instrument station and staff position becomes directly proportional to the staff intercept. So these are all about our today's PSC explanation about surveying and leveling. Students, please listen to each and every questions carefully and prepare well for the coming PSC exams. Stay tuned for our latest videos and please subscribe the channel if you are not subscribed and click the bell button for getting notifications. Thank you.